This is a walkthrough of problem 2 on practice exam 2 of module 7 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have a 5 kilogram horizontal pole attached to a building via a hinge, supported by a cable that's 3/4 of the way out. The cable makes an angle 30 degrees with the horizontal. What is the tension in the cable? And what are the horizontal and vertical components of the force the hinge exerts on the pole? So we have a good diagram. Let's add in the angle, 30 degrees right here. Now let's add the forces on the pole. We have gravity in the middle, straight down. We have the tension in the cable, along the cable. And we have the hinge force, which we don't know which direction it is. Something like that. We can figure that out later. The most efficient way to get the tension in the cable now is to take torques about the hinge. So let's put our axis of rotation right there. Gravity is clockwise. The tension exerts a counterclockwise torque about this point of rotation. The clockwise torque from gravity is the gravitational force, mg, times the perpendicular distance, which is L/2. It's already perpendicular. That's a right angle. All of gravity is rotating it. L is the length of the pole. We don't know what it is, but we know gravity's L/2 away. The counterclockwise torque from the tension in the cable, we need this component of the force. This is not at a right angle, so we need to get this component. That's T sine 30, the opposite side, that length right there. So the force that's perpendicular is T sine 30. The distance is 3/4 out. And there's the component right there, T sine 30. These torques must balance. The clockwise torques equal the counterclockwise torques. We can substitute 50 newtons in for mg, the mass of the pole, and we solve for the tension. And we get 67 newtons. That's part A. 66.7 newtons, we rounded it to 67. Part B asks for the horizontal and vertical components of the force the hinge exerts on the pole. So we're going to get that by setting the forces equal to 0 in the x and y direction. This thing is a static situation. Nothing's accelerating, nothing's rotating. And to make it easier, we break this tension, which is 66.7 newtons, into horizontal and vertical components. These are T sub x is T cosine 30, right there. Tension is 66.7 newtons. We get 57.7 newtons for the horizontal component of the tension. The vertical component is T sine 30, which is 33.3 newtons, right there. So what we're going to do is we're going to replace the tension with the components. The vector is going to go away. We put the components in, 33.3, 57.7. Now it should be pretty straightforward. Look at the diagram, think until you get it. The weight is 50 newtons, tension's holding up 33.3 of it. In order for there to be no force in the y direction, the hinge has to add 16.7 up. The tension is jamming the pole into the wall with a force of 57.7 newtons. The hinge has to be pushing back with a force of 57.7 newtons to make the net force in the x direction 0. So F hinge vertical, 16.7 newtons upward. F hinge horizontal, 57.7 newtons to the right. That's problem 2.